All right, so for the example, okay, I'll let you read through this, okay, and try to do it on your own. If you'd like a little bit of a hint of things you're gonna have to check, you can go ahead and copy this down and then go from there. But let me go ahead and pause the video and give it a try and then come back. All right, so I have written out what my mean is. So my mu D for this one is the mean difference in blood sugar levels between the current medication and the new medication. I'm setting it up with current minus new. They're trying to figure out which medication is doing better. Okay, so we're looking at the difference here. Okay, all right. So for this, our null hypothesis is going to be that the mean difference is going to be equal to 0. Okay, or if we're trying to figure out if the new medication is better, then mu D will be greater than 0. Okay. Yep. Okay, and then alpha is equal to 0.5. Okay, so now be careful. I know we've got three sets of numbers here. We are only worried about the difference. Okay, not the individual samples before that. Sorry. So when you're plugging in your numbers to your calculator to find your mean and standard deviation, we're using the difference. Okay, because only one sample. All right. So this comes out to be, we got 0.156 for our mean. We've got a standard deviation of 0.263, and I'm getting this from one variable stats on my calculator. All right. And then our N, we've got 16 individuals in our sample, which means our degrees of freedom is 15. Okay, so there's all that data. Okay, so let's see. Was it random? It does say somewhere. Where am I at? Where's it at? Okay, we'll be double blind, and the order of subjects receive the medicine will be randomized. Okay, so it is random. So treatments were randomly assigned. Okay, and then our normal check, N is less than 30. Okay, so we will check the data. Okay, so we put a little graph here. We have our mean difference here. We have our frequency over here. All right, so let's see, between negative 0.2 and 0, we have 5. We have 3 to 0.2. We have 5 to 0.4. We have 2 to 0.6, and we have 1 to 0.8. All right, so I don't see, there's no outliers or strong skewness. Okay, so we are safe to proceed with T procedures. Okay, so we're good to go there. Now we do our calculations bit. So we have a 1 sample T test for means. Got to find our test statistic here. So remember, T is equal to x bar minus mu naught. We've got S over square root of N. And when I replace that with all of my relevant information, we've got 0.156 minus 0 over 0.263 over the square root of 16, which when we throw that into our calculator, we get to 0.373. And then we just need a visual for this. Don't have to graph this if you don't want to, but remember we got 0 here. We're at 2.373 here, and we're trying to figure out everything on this side. Okay, so this is going to be a TCDF in our calculator with a lower bound of 2.373, an upper bound of positive infinity, and degrees of freedom is going to ask us for is 15. Okay, so when we throw that in our calculator, we're going to get a p-value of 0.0157, And then now it's not time for our conclusion. Okay, so 0.0157 is less than 0.5. Okay, so because our p-value of 0.0157 is less than our alpha of 0.5, we can reject the null hypothesis. Okay, so we have convincing evidence that there is a difference in the average blood sugar levels between the current medication and the new medication. All right, that's it for note 3. Next up is note